So, my dear friends, back to Pavilion. I'm coming to you with tutorial P6. We have completed transmission line protection by overcurrent and earth fault relays. Then I wanted to start distance protection. But meanwhile, I thought that let me think of the possible practicals or experiments that can be conducted in overcurrent and earth fault protection. And we have conducted many experiments in our engineering college, Birla Vishwakarma Mahavidyalaya at Vallabh Gujarat State, India. We have designed around 60 experiments of different kinds. Out of that, many experiments are on this overcurrent and earth fault relays. Some of them I am trying to show to you, and that also I am trying to show to you at a low cost. So there are many engineering institutes in Gujarat, Maharashtra, Karnataka, all over India and all over the world. Many would be carrying out the experiments. And the usual problem is that the institutions do not have big funds, big grants, so that they can have the experiments with very large expenditure. So I am suggesting the experiments with very low cost. So such low cost experiments up to P6, P5 we have completed, and this is P6. My friends, I'm sorry, this is not an experiment because before I come to the experiment on this relay, I have to talk about this relay. This is a new thing we are starting today. We have designed experiments on digital overcurrent and earth fault relay, numerical overcurrent and earth fault relay, if you want to say so. But there is a small small thin line of difference between digital and numerical overcurrent relay. But we had rather one digital overcurrent and earth fault relay type SPAJ 140C of ABB, Asia Brown Boveri, very well known name, and we had purchased that relay from them, and based on that relay we had designed few experiments so that when the student goes to the field practice, he would come to know as to how to use that relay, how to apply that relay, how to use the different facilities of the relay. So coming to that relay, to remind you, my phone numbers, my email ID is there. You are always most welcome to mail me or send me a WhatsApp on this number to understand anything in theory part, in practical part, in obviously power system protection. Yes, friends. So I have talked about this preface first, that I have to, before I talk about the experiment, I must talk a little about that SPAJ 140C. It's a literature of about 68 pages, a big long literature, which is freely available on website, ABB website. So I am doing nothing new. And if you purchase a relay, they give you that material. So I have that material with me. And you can also, anyway, if you like, you can go to website and free of cost you can have that material. So I'm not rather doing anything wrong with this, but then I'm using the relay of ABB SPECOM version. So I am really thankful to Asia Brown Boveri Limited who gave us such a good relay. But my friend, I should also tell that if I mistake not, and if I'm not wrong, that SPECOM version, there is a full SPECOM version, SPAJ 140C, SPAM, that is motor protection relay, SPAD, that is transformer differential, many other relay in SPECOM version. SPECOM version has been, as far as I know, it has been discontinued. It has been obsolete. Yet more modern, more recent relay, more latest relay, relays with many more facilities are now available. ABB has started Relian version relay, REF 615, REM, REG, RET, REL. So you see, many relays are there. And if time permits, someday we will talk about those relays also. But today, because we have designed and SPAS 140C is not useless. It is giving you many facilities. And as far as I remember and as far as I have heard, ABB has some relays in stock. Now they have stopped probably manufacturing, but some relays are in stock. So if you ask them, they are selling. So yet they are available, and they are obviously much more better than the old electromechanical relays. So we should be talking about that relay. And well, if we talk about that relay, that would be something really very worthwhile. So that is the reason why I have prepared the presentation. Presentation is mine. Presentation is not of ABB. So it is quite possible that I might have made some mistake in understanding a relay. So if you feel that there is some error, if some ABB person, if some person who is much more intelligent than me, if a person who is more conversant with power system protection, and if he says that I have told something wrong, then please excuse me, error is mine, error is not of ABB, because this presentation is mine. Yes, going further, at BVM Engineering College, Gujarat, India, we have designed a big laboratory, and we have designed an experimental SPAJ 140C, which used to consume about 8 hours of the students. So we had a 2-hour slot for experiment. So we had to take 4 hours for SPAJ. So many hours were obviously not available. So I was doing this as in extra sessions, and students were, out of 60 students, 40 were coming in extra sessions. And all those students are now very well placed. Some student is vice president in some company, some student is CEO, some student is vice chancellor. You see, many students have reached very good height. They have learnt a lot. So I was a key person in designing this experiment, and all other faculty members of BVM Engineering College also were with me. So let us understand this relay. It is a 3-phase relay. Facilities are I greater than, that is low overcurrent phase, low phase overcurrent. That is, it is a time delayed version, right? Relay, when the current exceeds the plug setting, when the current exceeds its pickup setting, the relay will operate after certain time delay. Then they have got I double greater than facility, which is so to say instantaneous, but they provide time delay there also. So it's a definite time version. There is an earth fault I 0 greater than. So sorry, uh, the person who has done this decoration for me has forgotten the word 0. It is I suffix 0. I 0 earth fault is there, and I 0 double greater than means earth fault instantaneous. Over and above that, breaker failure protection function is there. You see, in earlier relays, relay used to give signal to the breaker. Then nothing was with the relay. It was no responsibility of the relay whether breaker works or not. You see, it is quite possible that relay has given signal to the breaker, but breaker does not work. There is something wrong with the breaker. The trip coil of the breaker is open circuited. If it is a air blast circuit breaker or SF6 circuit breaker, the gas pressure is not enough. A spring has failed. Anything can happen. Any mechanical failure can happen with the breaker, or any electrical failure can happen with the breaker. Then, even if the relay has operated, because breaker has not tripped, the fault will continue. So, the damage to the system will occur. This relay has a capacity, has a facility to know that the breaker to whom it has given a signal has not worked, and therefore it will act. Either it will give an alarm, either it will give a signal, or it may even operate the upstream breaker. जो breaker fail हो गया, one breaker has failed, but the upstream breaker away towards the source can be tripped. So that facility is also there in this relay. It has got 6 output contacts. Out of them, 2 trip contacts, means they are heavy duty contacts, and 4 light duty contacts. Numerical display is there. There is a display which can display the setting values, measured currents, right? Even if the relay is not operated, but what is the current passing through the relay? R phase, Y phase, B phase, neutral, that the relay will tell. So you do not need a separate emitter, you see. Very good advantage. It will display fault values also. When the fault occurs, it will tell that this was the fault current, and the relay operated within so much of time, that the relay will tell. And not only once, last 5 fault records are possible. In modern relay REF 615, last 32 records, probably last 55 records are available, but in this relay, last 5 fault records are available. Then if there is something wrong with the relay, if relay has failed, then fault code also will be displayed on the numerical display. So that is, the relay has a facility of self-diagnostics. If relay hardware or software fails, it will let you know that I have failed. Relay will tell you that it has failed so that you can take actions. What is the technical data which is usually important? Relay is available in 1 ampere version, 5 ampere version. Continuous thermal withstand 400%. So from 1 ampere relay, if you pass 4 ampere for 365 days and 24 hours, nothing will thermally happen to the relay. Relay will not be damaged. Dynamic withstand, that is half wave, for half wave, 25,000%, right? 250 times the rated current you can pass for half wave. That is dynamic withstand. I greater than phase overcurrent setting range, which is 50 to 200% in our older electromechanical relays, and that too in 7 steps. That is 50, 75, 100, 125, etc. Here it is 50 to 500%, and in steps of 1%. You can set 50, 51, 52, 53. Oh, difficult. I cannot speak up to 500. Many steps, right? I double greater than setting is available in 50 to 500%. 50 to 500%. That is a phase overcurrent setting definite time. For inverse time, it is 50 to 500% of Phi. Time setting of definite time you need is 0.05 to 300 second. If at all you are using definite time characteristic, time setting you can do like this. But if you are using inverse characteristic, both is possible. Then TMS setting is available from 0.05 to 1, same as electromechanical or static relays. This relay gives many characteristics. Single relay gives extremely inverse, very inverse, normal inverse, definite time, long time inverse, rarely inverse, that is RI characteristics, in RX IDG curve. 7 different curves. No doubt one curve at a time, but single relay can be configured to have different characteristics. I double greater than setting is 0.5 to 40 times the rated current, 1 ampere or 5 ampere. Time setting in I double greater than 0.04 to 300 second. Usually 300 second is too much. If current is so high, 40 times, then the equipment will be damaged. So we need to trip within 0.04 second only, that is 2 cycles. And it is definite that there they do not give any inverse characteristic. I0 greater than setting range is 10% to 80%. Characteristics are same as phase over current. And I0 double greater than setting range is 0.1 to 10 times the rated current. So these are the so to say the characteristics of the, or rather technical data of the relay. What are the relay facilities? Relay can be used by manual push buttons. Step and program, only 2 push buttons are there. Push buttons are so good that 40,000 operations are possible. Up to 40,000 operations, nothing will happen to push buttons. One push button is step, which is known as reset also. That means using that you can reset also. Another push button is program. And by using 2 push button, you can completely configure the relay manually. If you don't want to do that, then you can communicate with a relay using PC, laptop, or any computer. But for that you have to download a software CAP 501, which they provide free of cost. ABB people provide free of cost. If you download CAP 501, using CAP 501, you can talk with the relay using PC, and that is very user friendly. Rather than manual, it is very user friendly. There are 3 switch groups for different functions. SGF switch group function, SGB, that is switch group blocking, and SCR, that is switch group relay configuration. In SGF, once again, there are 2, SGF1 and SGF2. In SGF, SGB only 1. In SGR3, SGR1, SGR2, SGR3. So, what are the functions of these 3 switch groups that we will see in next practical tutorials, right? So, because we are going to design an experiment on SGF, that how you can use the facility SGF1, then how you can use the facility SGF2, another experiment. Then third experiment, how you can use the facility SGB, similarly relay configurations. That those experiments we are going to talk about in the next practical tutorials, because we would want to keep these tutorials not very big, because otherwise people will not listen to it. No, people do not like to listen to 2 hours, 3 hours talk. So this will be about 35 minutes talk, so you can hear. Relay facilities, the operation indicators. What are the operation indicators? If I greater than start, that means if the current is more than plug setting, if you have set the relay at 1 ampere, and if current crosses 1 ampere, then indication 1 will come on display panel. Red indication 1 will come. You will come to know that the current has exceeded the plug setting. Yeah, try to understand. Relay is not yet operated. It is time delayed. But if relay trips due to that, then indicator 2 will come. Similarly, I double greater than start 3, I double greater than trip 4, I 0 greater than start 5, I 0 greater than trip 6, I 0 double greater than start 7, I 0 double greater than trip 8. And if circuit breaker fails, then number 9 will come. So these operation indicators will let you know what has happened in the relay. What has happened in the relay. Then there are registers. Certain registers. Register number 1 is fault current in R phase. Last 5 records available. What was the fault current in R phase when fault occurred? You see, fault current nobody can know. Emitter cannot tell you what is the fault current, because fault comes and goes within 0.1 second. Who will say? No emitter can tell you. And fault current is 10 times the rated current. No electromagnetic relay, no static relay was telling you what was the fault current. So you could not analyze. Here you can do all analysis. More than analysis, more important function is, if you know the fault current, then you know the distance at which the fault has occurred. So you immediately reach at that point and rectify the problem. So rectification of the problem is very fast because the fault current magnitude is available to you. Resistor number 2 is similarly for Y phase. Resistor number 3 is for B phase. Resistor number 4 shows maximum demand. So that what is the maximum demand during the day you can come to know. So that helps you in setting the relay. Resistor number 5 is time of operation for I greater than. And resistor number 6 is time of operation I double greater than. Everywhere last 5 records are available. So that means if the fault had occurred before 6 months, that data is available with the relay. 7. Time of operation of last 5 fault currents I0 greater than. 8 is I0. 8 is time of operation of I0 greater than. 9 is time of operation of last 5 fault currents I0. Right? So 7 and 8 are time of operation. 9 is the fault current, that is earth fault current. Register number 0 is that is for binary input. And register number A is there, that is a communication register. So these are the facilities. This is how the relay looks like. The relay panel looks like this. ABB name 50 hertz, 60 hertz, both versions are available. IN you can use 1 ampere, 5 ampere, both in same relay. It depends upon how do you wire the terminals, right? Then there is a drawing where R phase, Y phase, B phase are shown, and R phase, Y phase, B phase CTs are shown, and IL1, IL2, IL3 lamps will light. That means if there is a fault, then IL1 in fault in R phase, then IL1 will light, IL2, IL3 for 3 phases. I0 we are using CBCD, that is 4 balance CT. So that we call 3I greater than, that means I greater than in any of the phases. The auxiliary supply available is 80 to 265 volt AC or DC, anything you can use. Reset push button is shown. The program push button is shown, right? Then I greater than IN, that lamp will light, and in the display panel, what is the setting that will be shown? That is plug setting. In terms of I greater than divided by IN, it is a ratio. So if IN is 1 ampere, whatever is shown is the current value. But if IN is 5 ampere, you have to multiply by 5. Tk, that means if it is a definite time, then it is second. If it is K, that means if it is inverse, then it is TMS. Similarly, I double greater than, T double greater than, I0 greater than, T0 greater than, I0 double greater than by IN, T0 double greater than in seconds. All these values you can set, and that setting can be changed also. That setting can be changed manually using reset and program push button. There is a specific method which they are writing in their manual. I have written somewhere here. I will not read it out, but you can read it out afterwards. But that is a little time consuming, cumbersome also. More user friendly is using CAP 501. That means using the computer and software, you can easily talk with the relay. Right? SGF is the switch group function, SGB switch group blocking, SGR switch group relay configuration. Trip lamp will come if anything wrong happens with the relay. If the relay trips, then trip lamp will light. It's a red lamp, and there is one lamp IRF. You can see one lamp IRF. That is internal relay failure. If relay fails, then this lamp will be there, and some code will come. That code will, what is the meaning of that code that they are writing in the literature? You have to report to the manufacturer. They will come and rectify that problem, but they will rectify faster because they know what is the problem. Where is something wrong. Operation indicator we talked about 1 to 9, and registers we talked about 1 to 9 and 0 and A. All these things are available. So this is SPAJ 140C. How to configure the relay? How you will configure the relay? Operation in the setting mode. So this I avoid reading because you see it is little cumbersome. It is manual operation using. But if you use a computer, what you have to do? You want to set the current equal to 1.5 ampere. Just write 1.5 and relay set for 1.5. No doubt, if you write 1.5 in the computer, it does not reach to relay. So you have to download in the relay that setting. So relay will behave accordingly. So talking with the relay using PC or computer is much more, rather so to say, user friendly, right? So this manual I am not reading, but I have given when you read this when you are hearing this video, you can pause and you can read out this because this is available. Yes, I double greater than how to do, right? So same thing, manual setting mode, right? How to configure the relay SGF. SGF, how you will configure? SGF is a group which decides the characteristics. SGF is a group which decides the characteristic. Definite time, normal inverse, very inverse, extremely inverse, long time inverse, which kind of characteristic. And that kind of characteristic you can manually set. But once again, that is cumbersome. If you use a computer, then in computer you write very inverse. So, and download in the relay. Relay will be very inverse relay. I mean, very user friendly. So once again, I do not read this, but this manual setting mode is available. So this SCF manually, manual setting mode is available. So friends, this is all what I wanted to tell. How to use SCF, how to use SCB, how to use SCR, that we are going to talk in the next tutorial classes, right? So right now I just wanted to make you conversant with the relay, because this relay we have been working yet today I am seeing that most of the engineering colleges are teaching that disk type relay. I have been continuously telling to all the colleges that throw away that electromagnetic relay, throw away the syllabus, I mean throw away electromagnetic relay from syllabus also. Disk ही नहीं है, फिर कहाँ disk? I want to go to UK. I will not go by the horse ride, right? I will go by plane. So what? Why to study about how to go by horse? So the thing which is not being used, don't do it. So this is a new thing, and therefore I had to little talk about it. Many readers, many viewers might be knowing quite a lot. They might be knowing more than me, I do understand. But there may be many who might not be knowing. So I want them that they should know. They should throw away electromagnetic relay. They should throw away static relay also. And they should use this only, numerical relays, because the world is of numerical relay. So friend, with a sentence, I like to speak one sentence, you see, because after talking hard technical words, after boring you technically, a little thought. A woman is to be loved, not understood. किसी स्त्री को समझना नहीं है, आपको प्रेम करना है. मतलब वुमन तो कहने के खातिर किसी को भी, किसी आदमी को भी, you to your friend, to your father, to your mother, you have not to understand them, you have to love them, right? This is the first understanding. As such, all human beings are to be loved, not to be understood. And if you do that, this is the key to happiness. You will be happy. Everybody wants to be happy, but people do not know the key to happiness. So if you want to be happy, you have to follow certain things, right? So such sentences I get from saints, big saints, right? And I do note down. And when I note down, I feel like sharing it with my friends. So I'm sharing with you this. So friends, ending with this, don't forget this name, Adapt Me, because it is teaching you. I am not teaching. I could not have been able to teach. Adapt Me has given me this platform so that I can teach to the whole world. My son was telling that, Papa, आप 60 students को पढ़ा रहे थे, and you have worked for some 26 years. So 26 multiplied by 60. How many students do you have? You told hardly 1500 students. Now you will teach to 15,000 students, or 1,50,000, or 1 crore 50 lakh students. So Adapt Me has given me this platform. So I am thankful to Adapt Me. You should also be thankful to Adapt Me because you are learning from an expert person. So thank you, friends. Thank you so much and good day. Don't forget Adapt Me. Don't forget AppTrace. Thank you. Thank you, everybody.